Good evening. Today we are going to cover the two question we actually not two questions. One of the question we covered earlier in the assignment number 6, which is the robot utilization calculation. Now remember, I told you that I'm going to give you a simple way to do that, and just today I submit a blank paper with some lines, so you can, well, actually it's tables, so you can use it in the final exam to do the solution for this question if you are going to have it. So first we are going to start with the industrial robotic, and in this slide we are going to explain and discuss the most effective method to calculate the cycle time TC, the robot utilization time and the robot utilization percentage. So this was question number 2 in the assignment number 6. So we mentioned here that we can use either the equation method, the one you had in the example in the class, but the problem with this one that we should have the traveling percentage should be equivalent. For example, we had the time travel from point to point is A or 2A or 3A and extra, but in the question you had in the assignment we had different values, and this will make it harder if you are going to use the equation thing, because most of the time will be spent trying to find a relation between the traveling times. So in the case number 1, we said that the station is going to be manufacturing just one part on time. So the cycle starts from picking the part at the input point. So we are going to pick up the part number 1, travel from the input to the machine number 1, put down the part at machine number 1, we start the processing. After a certain time we are going to finish, so we have to pick out the part, travel it to the machine number 2, put it down, machining at the part number 1 at machine number 2, pick out the part number 1, traveling to the output point, put it down at output point, and then we have to travel back to pick another part and repeat the cycle. So if I'm going to tabulate in the sequence number 2, we can use both machines at the same time. That means we are going to have extra movement for the robotic arms. What happened is that at the minute we are going to finish the machining at the machine number 1, get rid of the part and get a new part and put it on the machine number 1. So machine number 1, machine number 2 are going to be busy at the same time, and the robot is going to make more traveling to pick and put down the parts on the both machines. So we can simply pick the part and do step number 1 to travel to the machine number 1. After machining at the machine number 1, we pick out the part and do the second trip to the machine number 2, put it down there, and we have to go back to the input point, pick a new part, make the movement number 4 to put it on the machine number 1. travel back to the machine number 2, waiting for the part at machine number 2 to be done. Take it up and put it to the output point. From output point, we travel back to the machine number 1, waiting for the part to be finished. Take it up and move number 8, which is going to take it to the machine number 2. Then we have to travel back to the input point, pick the third part, and continue the process. Do the step number 1, 2, and 3 continuously. Now, to make a table for that, I only just put the table one way again to start with the part number 1 and finish with the part number 2. I didn't continue the full table because it's going to be too long. I think this will be something about 30 to 35 steps, and this will make it very easy for you to do it in the exam. Now, I would like you to get a full mark for this question because nobody did in the previous year, because nobody got the chance to have a full explanation of this example. So to summarize the table, first pick up the part number 1 at the inlet point. Then travel to the machine number 1. Put it down at machine number 1. Start the machining at the machine number 1. This time will be added because actually the robot is waiting. Don't do any movement until the machining is going to be finished for the part number 1. Pick up the part number 1 from machine number 1. Go to the machine number 2. Put down the part at the machine number 2. We start to have the machining at the machine number 2. Now you can see that the time is 17.4, but actually this time is not going to be added. You can see that we had 11.4, but the machine will, the robot will simply travel to the input point once again and pick up another part. So we're not going to use 17.4, 11.4 plus the traveling time to the input point. This will make 11.9. And then we are going to pick up the part number 2 from the input point, and this will take something about 0.2 minutes, and this will make it totally 12.1 minutes. Travel with the part number 2 to the machine number 1, put it down there, start the machining. Now, till this moment, you can see that the machining of the part number 1 at the machine number 2 is going to last for 6 minutes, while the machining of the part number 2 at the machine number 1 is going to last for 10 minutes. So the best option is to travel back to the machine number 2 and wait for the part number 1 to be finished. So the next step is traveling to the machine number 2. So as we said here, as the machining time at the machine number 1 is 10 minutes, so thus the machining of the part number 1 and machine number 2 is going to finish first. So step 14 is going to be travel to machine number 2. Now, the trick is how to calculate the waiting time. Now, you can see that at the minute we put the part number 2 at machine number 1, it was 12.6 minutes. Then we spent first 23 minutes to travel to the machine number 1. So starting from putting the part at the machine number 2, and this will make it the step of the first yellow one. You remember the 11.9 minutes. Then when we travel from the machine number 2 to the input, 0.5, pick up at the input 0.2, let's make it 0.7, travel to the machine number 1, 0.3, let's make it 1 minute, then put it down at the machine number 1, and this will make 2.2 minutes, let's make it 1.2 minutes. Then we travel back to the machine number 2, and this will make it something about 1.5 minutes. So totally, since we left the part at the machine number 2, we spent 1.5 minutes. The machining time at the machine number 2 is 6 minutes, subtracting, and we're going to have 4.5 minute waiting time until the part number 1 to be done on the machine number 2. So the travel time from machine number 1 to 2 plus the pickup at the input, traveling to the machine number 1, putting down at the machine number 1. This one is repeated. The traveling time from 1 to 2 to be added, and by adding all these times we are going to have something about 1.5, and in this case the waiting time is going to be 6 minutes with the machining time at the machine number 2 minus 1.5, and this will make it 4.5 minutes. Finish with the part number 1 at the machine number 2, pick up the part, travel to the output, put it down at the output, travel back to the machine number 1. Now in this case we didn't travel back to the input because the machine number 1 is still busy doing the part number 2. We have to wait at machine number 1 for certain waiting time. Now let's check what will be this waiting time. So since we left the part at the machine number 1, we spent 0.3 minutes traveling from machine number 1 to machine number 2. Waiting time for 4.5 minutes at the machine number 2. This makes it 4.8. Plus 0.2, which is pickup time at the machine number 2. This will make it 5 minutes. Traveling from machine number 2 to the output is 0.4. Let's make it 5.4. Putting down at the output 0.2, and then we have to travel back to the machine number 1, and this will make it 5 minutes. So totally we are going to have 6.1 minutes has been spent since we left the part at the part number 2 at machine number 1. So the waiting time is going to be 10 minutes minus 6.1, and this will give us 3.9 minutes. So you can see that on the side we just added up the time, and till now we spent 22.6 to manufacture the parts number 1 and finish the part number 2 at machine number 1. So pick up the part from machine number 1, travel to the machine number 2, put it down at the machine number 2, and we start the processing there. Now we have to go back to the input and pick another part. Okay, machining process number 2. Okay, and then we have to go back to the input point and pick the part number 3. Pick part number 3, take it to the machine number 1, put it down at machine number 1, start the machining of part number 3 on machine number 1. Now we are going to redo the same sequence back to the machine number 2, waiting time for 4.5 minutes, pick it up when it's finished, and travel to the output point, put it down, and go back to the machine number 1 to continue the process. And then we can continue the process for multiple parts as we like to. Now, how to find what will be the cycle time in this case? Now, because we finished part number 1 and part number 2, simply if I'm going to take the total time when we left the part at the output point, which is the 30.1, and we go to the previous point when we put the previous part at the output point, we go up, and this will make it 18.2. If I go to subtract 30.1 minus 18.2, I'm going to have the time of the cycle work, and this will make it 30.1 minus 18.2, which is going to be equal to 11.9 minutes. So the cycle time to start producing the part after the first part is going to be 11.9 minutes. If you continue doing this table till the end, then you will find that the time is going to remain the same. Now I'm sorry that this lower bracket is only 30.6. Actually it should be at the 30.1. Now to find the robotic time, the same cycle time minus the waiting time for each part. So this will make it 11.9 minus the 4.5 waiting time at machine number 2 plus the 3.9, which is the waiting time at the machine number 1. And this will make the total time while we utilize the robotic arm for each part is going to be 3.5 minutes only. Now once again, you can find the robot utilization, which is going to be 3.5 divided by 11.9. Making more parts will simply increase the utilization of the robot. Now I think this will be enough for this example. I think we have only one point about one of the part number C in the question we had in the assignment is how we can increase the production rate and minimizing the robot movement simply if we are going to use what we call double grabber. Now you can see that this one is holding two parts. Now consider that the one on the right is part number 1, the other one on the left is the left is part number 1, on the right is part number 2. So we put the part number 1 and we don't have to travel to the other machine to pick the part. So simply when we finish the machining of the part number 1 on the machine number 2, we pick it up, then the robotic arm will rotate and leave part number 2 and travel to the machine number 2 to finish the process. Now the other example I would like to discuss